You think you're solid? You think this table is solid? You think the ground beneath your feet, the walls around you, the chair you're sitting on, you think they're solid? They're not. They're not even close. Everything you see, everything you touch, everything you think is real and solid and substantial. It's almost entirely nothing. Empty space, void. And I don't mean a little bit empty. I mean almost completely empty. More than 99.99999999999% empty. The universe is mostly nothing. And once you understand why, once you see what's really there, you'll never look at the world the same way again. Let me start with something simple. An atom. You've heard of atoms, right? The building blocks of matter. Everything is made of atoms. You, me, this table, the air, the stars, everything. Atoms. Now, if you think of an atom like they show you in textbooks, it looks like a little solar system. A nucleus in the center like the sun, and electrons orbiting around it like planets. Nice picture. Simple, but it's completely wrong. Not just a little wrong, completely wrong. First of all, the scale. The scale is absurd. If you took the nucleus of an atom and blew it up to the size of a pea, a little green pea you eat at dinner, how far away would the electrons be? You might think, oh, maybe a foot away, maybe across the room. No, the electrons would be a kilometer away, 1,000 meters, more than half a mile. That's the scale. The nucleus is tiny, incredibly tiny, and the electrons are way, way out there. And in between, nothing. Empty space. Just nothing. But wait, it gets stranger. The nucleus, that little pea in the center, almost all the mass of the atom is in there. More than 99.9% of the mass. The electrons are almost nothing. They're so light, so insubstantial, they barely count. So when you add it up, when you look at what an atom actually is, it's a tiny, tiny, unbelievably tiny nucleus with almost all the mass, and then a huge empty space, and then some electrons floating around way out there. That's an atom. Mostly nothing. Now, you're made of atoms. Trillions and trillions and trillions of them. Every cell in your body, every molecule, it's all atoms. And every single one of those atoms is mostly empty space. So when you put them all together, when you build a human being out of atoms, you're building something that's almost entirely empty space. If you could squeeze out all the empty space, if you could compress all the actual matter in your body, all the protons and neutrons and electrons, if you could squeeze it all together with no empty space, how big would you be? How big do you think? You'd be smaller than a grain of dust. Way smaller. All the actual matter in your body, if compressed, would be about the size of a small particle, invisible to the naked eye. And that's not just you, that's everyone, that's everything. This entire planet, all the mountains, all the oceans, all the cities, all the people. If you remove the empty space, the whole Earth would fit inside a stadium. Maybe smaller. The universe is almost entirely empty space. We're living in a universe that's mostly nothing. So why does anything feel solid? If you're mostly empty space, if this table is mostly empty space, why can't your hand pass through the table? Why does it feel solid? What's stopping you? And this is where it gets really interesting. Because the answer is not what you think. It's not that the atoms are touching each other. They're not. Atoms never touch. Ever. When you touch something, your atoms are not touching the atoms of that thing. They're getting close, very close, but they never actually touch. So what's stopping them? What's pushing back? Forces. Electric forces. See, the electrons in your hand, they're negatively charged. The electrons in the table, they're negatively charged. And like charges repel. They push each other away. So when you push down on the table, the electrons in your hand get close to the electrons in the table, and they start pushing against each other. The closer they get, the harder they push. And that push, that repulsion, that's what you feel as solidity. That's what stops your hand from going through the table. It's not matter touching matter. It's forces pushing against forces. You never touched anything in your life? Not really. You've only felt the electric repulsion between electrons. But here's the thing. Those forces, as strong as they feel, they're not filling the space. The force is there, yes, but the space is still empty. There's no stuff in between, no substance, just fields, electric fields. And a field is not a thing. It's not matter. It's a property of space. It's a region where a force can act, but it's not filling the space. The space is still empty. Now let's go deeper. Let's look at the nucleus, that tiny pea in the center of the atom. What's inside it? Protons and neutrons. And you might think, okay, finally, here's the solid stuff. Here's the real matter. But no, protons and neutrons are not solid either. They're made of quarks, 3 quarks each. And quarks, as far as we can tell, are point particles. They have no size, no volume. They're mathematical points, 0 size. And in between the quarks, you guessed it, empty space. Well, not exactly empty. There are gluons, the particles that hold the quarks together. But gluons are also point particles, no size. So even the nucleus, even the thing that has almost all the mass, even that is mostly empty space. So where is the mass? If everything is empty space, if particles are just points with no size, where does the mass come from? And this is one of the deepest questions in physics. Mass doesn't come from the size of the particles. It doesn't come from how much space they take up. Mass comes from energy. E equals mc squared. Energy and mass are the same thing, the mass of a proton. Most of it comes from the energy of the quarks moving around inside and the energy of the gluons holding them together. It's not the stuff. It's the energy, the motion, the forces. That's where the mass is. And if you go even deeper, if you ask what an electron is, what a quark is, what any fundamental particle is, the answer gets even stranger. They're not little balls. They're not little points bouncing around. They're excitations in quantum fields. The universe is filled with fields. The electron field, the quark field, the photon field, all these different fields permeating all of space. And what we call a particle is just a little ripple in that field, a wave, an excitation. It's not a thing, it's a pattern, a vibration in the field. So when you really look at it, when you dig down to the bottom, there is no stuff. There are only fields, and the patterns in those fields. And most of space, the vast overwhelming majority of space, has no patterns at all, no excitations, no particles, just the background hum of the quantum fields. Empty, or as close to empty as anything can be in quantum mechanics, where even empty space is never truly empty because of quantum fluctuations, virtual particles popping in and out of existence. But that's another story. The point is, you are mostly nothing. The universe is mostly nothing. And the little bit that is something, the particles, the excitations, they're not solid. They're not stuff. They're patterns, vibrations, waves in a field. And that is beautiful. That is profound. Because it means the universe is not made of things. It's made of processes, of interactions, of relationships between fields. Matter is not fundamental. Matter is what happens when fields interact. And this changes everything. This changes how you think about reality. You look at your hand and you think it's solid, but it's not. It's mostly empty space with a few electrons buzzing around and a few nuclei held together by forces. And the whole thing is just patterns in quantum fields. You are not a collection of things. You are a process, a pattern, a wave propagating through space and time, and so is everything else. Now, why does this matter? Why should you care that you're mostly nothing? Because it tells you something fundamental about the nature of reality. It tells you that what you see is not what's really there. Your senses lie to you. Your brain creates the illusion of solidity, of substance, of things. But underneath, it's fields and forces and mostly emptiness. And that's not a bug. That's a feature. Because if atoms were actually solid, if they were little hard balls that actually touched, chemistry wouldn't work. Biology wouldn't work. Life wouldn't work. You need the empty space. You need the forces. You need the quantum mechanics. You need the strangeness, because that's what allows complexity. That's what allows atoms to bond together in different ways, to form molecules, to form proteins, to form cells, to form you. The emptiness is not a lack, it's a possibility. It's room for things to happen, for interactions, for change. If the universe were completely full, completely solid, nothing could move, nothing could change, nothing could happen. It's the emptiness that allows motion, that allows time, that allows cause and effect. The emptiness is as important as the matter, maybe more important. And here's the really wild part. We don't even know if space itself is something or nothing. Is space a thing that exists? Or is it just the relationships between things? Is it a container that holds matter? Or is it defined by matter? These are open questions, deep questions. Questions we're still trying to answer. Some theories say space is made of something, some kind of quantum foam at the smallest scales. Other theories say space is emergent. It's not fundamental. It arises from something deeper. We don't know yet, but what we do know is that the universe is far stranger, far more empty, far more mysterious than it appears. You think you know what's real. You think you know what's solid, but you don't. Nobody does. We're all living in a universe that's mostly nothing, held together by forces we're still trying to understand, made of patterns in fields we can barely visualize. And that's okay. That's exciting. That's what makes physics fascinating. We don't have all the answers. We probably never will. But we can keep asking questions. We can keep digging deeper. We can keep trying to understand what this strange, beautiful, mostly empty universe really is. So next time you touch something, remember, you're not really touching it. You're feeling the electromagnetic repulsion between electrons. Next time you look at something solid, remember, it's mostly empty space. Next time you think about what you are, remember, you're a pattern, a process, a wave in the quantum field. You're mostly nothing. And that's the most wonderful thing in the world.